So now in the second year you are studying what is that? Relations and functions. So last year already you studied this relations and functions. In this relation means relating the two terms or two concepts or two objects or two quantities. Okay, so for example, the number of students in the second PUC of a school, and let B be the another one of the set. You can consider it is the set of students in the first PUC of the same school. So that is about a relation. You can consider any types of relations, but in that domain, range and codomain are the different three words are there. Domain means here I am writing the one of the relation here. So 1 1 1 2 1 3 1 2 and 2 3 it is there. So in this relation you can consider what is that domain. Domain is first one, right? First one what we are writing, the first one 1 1 1 2 and 4, right? The domain is what is that 1 2 and 4 you can write. Then what about the range here? So range is what are the answers we are getting? That is 1 and 2 and 3. So these are the range. When you are taking the values and substitute it, we will get the range. So for the best example you can consider A comma B is belongs to A into B, A into B across B is A is brother of B. Okay, so this is our relation. You can consider it. A comma B is belongs to A cross B, it means A into B. A is a brother of B. Okay, A is a brother of B. Then generally, how can you write this one in the relation form? A comma B is belongs to R. So we say that A is related to what we can write? A is related to B under the relation. What is the relation here? Under the relation R. So how can we write this sentence? We can write that sentence in the form of A or B. It means A related to B. So in generally A comma B is belongs to R. A comma B is belongs to R we can write. So these are the things you all know in the last year, right? So now in this year with the relations and functions, in this year we can take some different types. What is that some different types? So there are three types are there. Okay, so one is empty relation. What is that empty relation? A relation, this is what empty relation. What is this empty relation? Okay, so there is no relation between the two sets. That is what empty relation. It means there is no elements of A is related to any element of A. That is R equals to I, null set. It's a subset of A cross A. Okay, so there is no relation. There is no elements. So in one word what we can say, the empty relation is if the relation is having no elements. A relation R is set A is called as empty if there is no element of A. This is our empty relation. Okay, now next one relation is universal relation. What is this universal relation? Universal relation means a relation R is a set A is said to be a universal relation if each element of A is related to every element of A. Is related to every element. Of A. It means R is equals to A cross A. Okay, so here the empty relation is R is null set, there is no element, it is a belongs to what is that? It's a subset of A cross B. It means no elements. So no elements means it's empty relation. And the second one is universal relation is a relation is R of a set A. Each element of A is related to every element of A. Every element of A. It is called as what? Universal relation. How can we write like this one? So R equals to A cross A or A into A. Both the empty relation and universal relation are sometimes are called as the trivial relation. So both the empty relation and universal relations are there now. So that is called as trivial. Okay, so trivial relation. So this is our one of the type. So how can why when we are saying the trivial relation, it has both empty relation and the universal relation, or sometimes we call it as it is our. Okay, now we can see the some of the example. Now in that example, so now in last year you studied set builder method and roster method, you know that. Okay, so set builder method and roster method, you know. So in the relation R, a relation R in the set, relation R in the set, you can consider 1, 2, 3 and 4 is defined by R equals to A comma B, then B equals to A plus 1. Okay, A plus 1 is also expressed as A or B. It means A related with the B, you know that. Now if and only if B equals to what is that? A plus 1. So when we are saying A related to B, so B if and only if B equals to A plus 1. The set is what? 1, 2, 3 and 4. These are the elements are there in the set. But here we have to write A comma A means A equals to, we can consider it as 1. So when we are taking the, how can we write the relation now? So relation is A equals to 1. What about the B? B equals to 2. And A equals to 2. What about this? B equals to 3. And A equals to 3, and this is what? 4. So these are the what relations we are getting. We cannot take 4. Why? We cannot take 4. 4 plus 1 is 5. 5 is not there here, right? So here it is 1, 2, 3 are the domain, and 2, 3, 4 are the range. Okay, so here in this case we can consider it is our equivalence relation. Equivalence relation. So now next is we have to take the different types now. One is reflexive. One is what? Reflexive. And the second one is symmetric. Reflexive, symmetric and transitive. So now I'll explain what is this transitive. Okay, so transitive. Reflexive means what? Symmetric means what? And transitive means what? These are the three different types. In this year you are going to study. So here a relation R is said to be a. R is a relation of the set A. We have to consider R is A is called as reflexive. When we are saying it is a reflexive, means if A comma B is belongs to R for every A is belongs to A. Okay, so for every A is belongs to A, and when we are saying this is a symmetric, this is what Nash said is symmetric. When we are saying this symmetric, if A B is belongs to R, A is belongs to R, and that implies B and A is also belongs to R. B and A is also belongs to R. So for all A comma B is belongs to A comma B is belongs to A. Okay, so reflexive means A comma A is belongs to R, A comma A is belongs to R, and reflexive symmetric means A comma B is belongs to R as well as B comma A is belongs to R. Okay, now the last one is remaining, it is a transitive. So what is the transitive now? When we are saying it's a transitive, if A comma B is belongs to R, and if B comma C is also a belongs to R, then A comma C is belongs to R, then only we can say here A B C R belongs to A. So A and B C R belongs to the set A. Okay, so this is what transitive. I hope that all of you clear now. A comma B is belongs to R, B comma C is belongs to R, then A comma C is belongs to R, but A, B and C are the belongs to A. So now what is reflexive? Reflexive means it's a relation. In that relation, A is the different types of sets. In that set, here we can consider it's a reflexive. A comma A is belongs to R. So for example, here it is there, one of the example I wrote here, 1 comma 2, 1 comma 2, 2 comma 3, 3 comma 4. It is there in the reflexive form? No, it is not there here. Why? 1 comma 1 is not there, and also 2 comma 2 is not there, 3 comma 3 is not there, or 4 comma 4 is not there. So A comma A means 1 comma 1 or 2 comma 2 or 3 comma 3. So like this, 1 comma 1, 2 comma 2 or 3 and 3. So these types are there, means it is about reflexive. Now symmetric we can check. 1 comma 2, here A comma B is belongs to R, and B comma A is belongs to R. So 1 comma 2 is there. Now what about the, if we want to say it is a symmetric, 1 comma 2 and 2 comma 1 it should be, right? So here 2 1 is there, no it's not there. Here 2 3 is there, and 3 2 is not there. Here 3 4 is there, and 4 3 is not there. So it is not a symmetric. Okay, so now lastly it is for transitive. Transitive means A comma B is belongs to R, B and C is belongs to R, and that implies what? A comma C is belongs to R. So you can write here 1 2 2 3 and 3 4. Okay, so it is now also not a transitive also. So it should be, if you want to say the transitive, how can you, how it should be? 1 2 and 2 3. So 1 2 2 3 and 1 3 it should be there. It is what? 1 3, 1 2 and 2 3. 2 2 is a common, then 1 and 3 is, it should be remaining. So 1 3. Okay, then only we can say it is what? Transitive. So I hope that all of you clear now. Okay, so now if it is satisfying all these reflexive, symmetric and transitive, then we are saying the different words. That relation is called as equivalence relation. So what is relation? What's the name of this relation? Equivalence relation. Clear? So what is equivalence relation? So equivalence relation is when the relation is satisfying with the reflexive, symmetric and transitive. Reflexive, symmetric and transitive. Then only we can say this is what? Equivalence relation. Okay, so for example, I will say, give an example to you now. Show that, okay, so this is what example I am taking now. Show that set 1 2 3. Show that the set belongs to a 1 2 3 and the relation is belongs to 1 1 2 2 3 3, 1 2, 2 3. Okay, so now we have to show that it is a reflexive or symmetric or transitive. Okay, now I am checking now. So 1 comma 1 is there. So now for reflexive, so for reflexive, so what it should be? Reflexive since 1 comma 1, 2 comma 2 and 3 comma 3 is there, right? This is what reflexive. 1 2 3 are the sets. What are the sets? It should be 1 comma 1, 2 comma 2 and 3 comma 3. So all the relations are there, 1 1, 2 2 and 3 3, it is there. So it is what? Reflexive. Clearly we can say it is what? Reflexive. Why? These all the heads are there in this R. Okay, now next is what we have to check, whether it is symmetric or not. Symmetric or not. Symmetric means, already I said, 1 2 it is there, then 1 2 it is there, it belongs to R. Okay, but 2 comma 1 is does not belongs to R. Clear? So 1 comma 2 is there, it belongs to R, but what is not there? 2 comma 1 is does not belongs to R. Is there any 2 comma 1 here? No, 2 1 is not there, only 1 2 is there. Therefore it is not a symmetric. So you have to write, but R is not symmetric. Next you have to check what is that? Transitive. What is this? Transitive. So you have to check the transitive. For example, here 1 2 is there, 1 2 and 2 3 is there. Okay, but where is 1 3? 1 3 is not there. Is there 1 3 here in this relation? 1 3 is there? No, it is does not belongs to R. This is belongs to R, this is belongs to R, but 1 3 is does not belongs to R. Therefore R is not transitive. R is not transitive. So what is a clear statement we can say now? Here only the reflexive it is possible. It's what? Reflexive, but neither symmetric nor transitive. It means these two, transitive and symmetric, it is not possible to say. Only that we can say it is what? Reflexive. Now it is a equivalence relation? No, it is not a equivalence relation. Why it is not equivalence relation? If you want to satisfy the equivalence relation, all the reflexive, transitive and symmetric it should be. So that's why it is not a equivalence relation. Okay, now I move to that exercise part. Exercise 1.1. Okay, I'm taking now exercise 1.1. So exercise 1.1, first question, determine whether each of the following relations are reflexive, symmetric and transitive. Reflexive, symmetric and transitive. Okay, so here in the first question there are 5 sub questions are there. First one, second one, third one, fourth one and fifth one. In this fifth, A, B, C, D, E. So these are the questions are there. So I will explain to you how to simplify these questions. So now here the first question is, relation R in a set A. Relation R in a set A. A is 1, 2, 3, dash, 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 13 and 14. Okay, is defined as R equals to x comma y. You know this, these all are, how to write this? 3x minus y equals to 0. So this is our relation, this is a condition. But the set contains, what is set? A equals to 1, 2, 3, 4 up to 14. Okay, so now what are the relations I am getting? So therefore relation R equals to, what are the relations I am getting? First I want to take it 1 and substitute it here. So 1 into 3 is 3, then this 3 goes to other side is minus 3. So therefore what? Y equals to 1. It means 1 comma 3 is the one of the relation. How we are getting? So let us see now. Here I will explain. 3 into 1. 1 is what? X is 1, no? Minus y equals to 0. So now this is what? 3 1s are 3. 3 minus y equals to 0. Minus y equals to minus 3. This get cancelled. So So y equals to what? 3. So this is what? Y 1 comma 3 is our first relation. Next, if I want to take this 2, if I am taking 2 into 3 is 6, then this goes to other side is what? 6. Okay, this is the next term. Next relation is what we can write. I want to take it as 3 3 are 9, so it is what? 9. Next 4 3 are 12. Okay, so same thing you have to do it. Next 5, if I am taking 5 into 3 is 15. Here in this A set 15 is not there. Is that 15? No, 15 is not there. So these are the relations. How can we write the relations? Understood? No, 1 2 3 4 up to 14 they are there, but the condition is what? 3x minus y equals to 0. Take the value 2 here, you will get 6, and then this is what? 6 minus 6, so y equals to what? 6. Suppose if I am taking 10, 3 into 10, so I end up with this only the 12. If I am taking 10, what is the answer you are getting? You can see. So y equals to what? 30. 30 is there in the set A? No, 30 is not there. Therefore, that is not a range. Only that we are getting 1, 3, 2, 6, 3, 9, and 4, and 12. So now we have to check whether it is a reflexive. Whether it's a reflexive. R is not a reflexive. R is not a reflexive. Why it is not a reflexive? Why it is not a reflexive? So here, since 1 comma 1, is there 1 comma 1? No. Is there 2 comma 2? No, and so on. Is there 14 comma 14? No. So does not belongs to R. So reflexive should be no 1 1, 2 2, 3 3, and 4 4. So it is not belongs to R. Now transitive. Sorry, symmetric. No, next is symmetric. Okay, now if I want to say the symmetric, 1 comma 3 and 3 comma 1. So 1 comma 3 is belongs to R, but 3 comma 1 is does not belongs to R. Okay, so therefore it is not a symmetric. Therefore R is not symmetric. So I hope that all of you clear now. So now last one, I have to check whether it is transitive or not. Transitive. So now transitive means, is it a transitive? No. 1 comma 3, 3 comma 9 are there, then 1 comma 9 is not there. So this is belongs to R, this is belongs to R, this is does not belongs to R. It is does not belongs to R. Therefore R is here. This is also what? Not a transitive. So no, now transitive. Now what is the conclusion statement? It is R is neither reflexive nor symmetric nor transitive. R is neither reflexive. R is neither reflexive nor symmetric nor transitive. Okay, so nor symmetric nor transitive. So I hope that this is clear for you. Okay, so now one more relations I am taking now. R is a set of natural number. R is a set of natural number. R is a set of natural number. So R is a set of natural number. But the condition is what? R equals to x comma y, such that y equals to x plus 5 and x is less than 4. So these are the conditions. So what about the relation now? So relation we can write 1. First is what? 1 plus 5 is 6 we are getting. So you can write it is what? 6. Next we want to take it as 2. 2 plus 5 is 7. Yes, this also belongs to a natural number. Next term is what? I have to take it as 3. 3 plus 5 is what? 8. And 4 4. Should I take the 4? No, it is not possible to take the 4. Condition is what? X is less than 4. X is less than 4. This condition is satisfying, means this condition is there, so we cannot take 4 comma 9. Okay, so the relation is 1 comma 6, 2 comma 7 and 3 comma 8. So now you can say whether it is a reflexive or transitive or symmetric. See, is it symmetric? It is a reflexive? No, it is not a reflexive. So clearly 1 1 2 2 1 1 2 2 and 3 3, it's not there, and so on. It's what? Not there. Clear? So now it is not a reflexive. It's not reflexive. Okay, so now symmetric. We want to check the symmetric. 1 comma 1 is not there, so it is what? Not reflexive. Now 1 comma 6 is there. 1 comma 6 is belongs to R, but 6 comma 1 is does not belongs to R. Therefore R is what? R is not symmetric. R is not symmetric. So now lastly, here, since there is no pair in such R, xy and yz is belongs to R, so we need not order pair x comma z in R. Therefore R is what? Transitive. So whatever the values we are getting here, we can take it as a what? A transitive. How it is transitive here now? Since there is no pair in R such that x comma y and y comma z and y comma z, so these all are both are belongs to R, so we need not order pair x comma z in R. Okay, so need not be parallel. Therefore R is what? R is transitive. R is transitive. Anyhow, this z x comma z is not coming only. Why? So these are also not possible. Okay, clear? So now this is what? R is neither reflexive nor symmetric, but it is a transitive. It is what? Transitive. So next condition is what? Set A. The third one is A is given. A is 1 2 3 4 5 6. So this is the one of the very easy one. What is the relation condition is given? So condition is x comma y, and y is divisible by x. So this is a condition. Y is divisible by x means therefore R equals to what now? So y is divisible by x. Y is divisible by x means, so these are the terms we are getting. A is a set of 1 2 3 4 5 6. So we can say the relation is y is divisible by x. 1 comma 1 we can write 1 comma 1. So many things are there. Divisible by 2, then 2 comma 2, 3 comma 3, all are there. It is 6 comma 6 also we can write. Next, y is divisible by x. Y is divisible by x. So for example, 4 is divisible by 2, no? It means 2 comma 4. Okay, so these all are the terms we can write. So many terms we can write. So I am not writing this one. The statement I am writing in the other way now. So now it is, we know that any number x is divisible by itself. So we know that any number is divisible by itself. Any number is divisible by itself. It means 1 comma 1 is divisible, 2 comma 2 is divisible, or 6 comma 6 is divisible. Therefore we can say R is reflexive. Therefore we can say R is for reflexive. Now we want to check it is symmetric. So one term I wrote here, 2 comma 4 is belongs to R, but 4 comma 2 is does not belongs to R. Our condition is y is divisible by x. Y is divisible by x means this 4 is divided by 2, it means the answer is 2, but 2 is does not divided by 4. Okay, therefore R is not symmetric. R is not symmetric. Okay, so R is reflexive but R is not symmetric. Then we want to check it the transitive. Let x comma y is belongs to R and y comma z is also belongs to R. Then y is divisible by x and y is divisible by here divisible by x and z is divisible by y. So y is divisible by x and z is divisible by x. So anyhow we can say it is what x comma z. It means z is divisible by x. Yes or no? So if that both the terms are divisible by this and that, so what we can say? R is reflexive. Sorry, R is transitive or not? Z is divisible by x, y is divisible by x, and z is divisible by y. So that z is divisible by x. Therefore, R is transitive. R is transitive. We can say R is what? Transitive. So clear? So third one is over now. Now fourth one, condition is what? R is a condition. So fourth problem is relation R in the set Z. So relation R in the set Z, which is a set is Z for all the integer is defined as R equals to x comma y. This is a what relation we have to write such that x minus y is an integer. Is an integer. Okay, so x minus y is an integer. So now it belongs to what? Z. Everything is belongs to Z. How can you write now? Is it a reflexive? Is it a reflexive? Okay, now we will check. Now, so I want to check it is what a reflexive or not. Reflexive. How can you check it is a reflexive? Now x is belongs to Z. X is belongs to Z means x comma x is belongs to R. X comma x is belongs to R as x minus x equals to 0. Is an integer or not? Is an integer. It means x minus x is what? 0. So x minus y is there. Y is also x and x is also x. So x minus x is 0. Therefore R is reflexive. Therefore R is reflexive. Next is symmetric. So now you tell me either it is a symmetric or not. Tell me either is symmetric or not. So for every x comma y is belongs to Z, if x comma y is belongs to R, then x minus y is an integer. You know that this is what given integer, but we have to check whether it is what that implies minus of x minus y is also an integer. How we are getting this integer? See how we are getting this integer. X minus y is an integer, but y minus x we have to check whether it is integer or not. Yes, minus of minus x minus y minus x is integer, is an integer. So why it is integer? Minus of x minus y, reverse order we have to write. So y minus x is also a integer. Therefore y comma x is belongs to R. So R is symmetric. So now we have to check whether this is a transitive or not. So now lastly we have to check it is what? Transitive. Okay, so now tell me whether it is a transitive or not. Is it a transitive? Yes, we have to check whether it is a transitive or not. Let x comma y and y comma z is belongs to R. Is belongs to R where x comma y comma z is belongs to z. Sorry, it is what z, right? Right. Now this implies y x minus y and y minus z, x minus y and y minus z are integer. X minus y and y minus z are integer. For example, 2 minus 1 and 1 minus 2. Answer is 1 and minus 1. So 1 and minus 1 are all are the integers. You know that. But similarly, what we can say, x minus y and y minus z are integers. X minus z equals to x minus y plus y minus z is an integer. Is an integer. So x minus y and y minus z. So what are the answer we are getting? That is also what, x minus y plus y minus z. No, so plus y minus z to get cancelled. X minus z is remaining. So it is also an integer. Therefore R is transitive. Therefore R is transitive. Now what is the conclusion statement we can say? It is a reflexive, symmetric and transitive. If both are satisfying, so one more relation, what we can say? Equivalence relation. What is that relation? Equivalence relation. Yes. Okay. Now fifth one. There are 5 questions are there. A, B, C, D. That A, B, C, D you can check maybe. So I will say only the first one now. Fifth one. R is x comma y. X and y work at same place. X and y work at same place. It means both x and y at works at the same place means reflexive it is there or not. X comma x is reflexive and y comma y is also what? Reflexive. Both are work at the same place. Now next, x comma y is both are work at the same place, and y comma x you can consider it. Both are work at the same place, x comma y or y comma x. Understood now? X and y or y comma x. So they are working in the same place. X is a one person and y is a one person, and y is a one person and x is a one person. So you can consider it. It is also a transitive. Sorry, symmetric. Okay. Now another one. X and y are works at the same place, and y and z also work at the same place. Then if both x and y and z are working at the same place, but x and z also working at the same place, so what we can say? It is a reflexive, it's a transitive, and it is a symmetric. Clear? So that is the first one. Next, x and live in the same locality. X and y in the same locality. Yes, x and y in the same locality means if he are in Baindur, it's one of the area we can consider it. X and y are the same means x and x also located in the same area, and y comma y is also located in the same area. Therefore, what we can say, it's lie in the same locality means it is a what? Reflexive. Next, x comma y and y comma x both are live in the same locality, it is symmetric. If x and y and z are located live in the same locality, then x comma z is also live in the same locality. Therefore, it is, we can say, it is symmetric, transitive and reflexive. So now next one is x is exactly 7 centimeter taller than y. X is exactly 7 centimeter taller than y. X comma x is it belongs to R. X is exactly 7 centimeter taller than y. So it means since human being x cannot be taller than himself, it's not possible. Suppose for example my height is 5.2 feet means it is not possible to taller than my height. It's not possible. So for example your height is 5 feet means is it possible to taller than you? No, it's not possible. Your height is already, it's a fixed. It's what, 5 feet. okay, or 4.5 feet. Is it possible to taller than you? It's not possible. Therefore, x comma x is not belongs to R. X comma x is not belongs to R. So R is not a reflexive. Then you can consider it's the next x comma y. X is exactly 7 centimeter taller than y. Y is not taller than x. Clear? Understood? X is exactly 7 centimeter taller than y. So for example, this is what x and this is what y. X is exactly 7 centimeter taller than y. Here this is smaller or this is smaller. This is small. For example, I am taking x is smaller and this is what larger. So is it possible to say in the reverse order? It is not possible. Okay, therefore x comma y and s belongs to R, but y comma x is does not belongs to R. So it is need only x centimeter taller than y. Then y is exactly 7 centimeter shorter than x, not taller than. Okay, so now if both the two are not possible, means maybe it is a transitive is also not possible. Yes, x comma y and y comma z is belongs to R. Okay, x is exactly 7 centimeter taller than y and y is exactly 7 centimeter taller than z. X is exactly 14 centimeter taller than z. Now y 7 centimeter and 7 centimeter. X is exactly 14 centimeter taller than z. X and z is belongs to R, or it does not belongs to R. It's 14 centimeter, not 7 centimeter. Okay, so R is not a transitive. Therefore, the conclusion is hence R is neither reflexive nor symmetric and nor transitive. And D1, X is the wife of Y. X is the wife of Y. Okay, now X comma X, is it belongs to R? X is wife of X, is it possible? No, X is wife of Y, no. X is wife of Y. X is wife of X, is it possible? It's not possible. Then therefore it is not a reflexive. Next, x comma y is belongs to R means x is wife of y, but y is not a wife of x. Only x is a wife of y, but y is not a wife of x. So it is not a reflexive also. Okay, sorry, it is not a symmetric. Now next, clearly x is wife of y and y is wife of z, and then it does not x is the wife of z. This does not x is wife of z. Therefore x comma z is not a relation with R. Therefore R is not a transitive. So now what we can say here, R is neither reflexive nor symmetric and nor transitive. Then lastly, last problem, it is that x is the father of y. Okay, x is the father of y. X is the father of x. It's not possible. But x is the father of y, right? So R is not a reflexive. Next, if x is a father of y, but y is not a father of x, therefore R is not a symmetric. And x is a father of y and y is a father of z. X is a father of z? No, it's not possible. So that x is not a father of z. Therefore it is only this is not a transitive. So we can say what R is not transitive, not reflexive and not symmetric. Okay, clear? So now question number 2.